Okay, so we found G, or we found little g from big G in the last video. Let's do something else. Let's find how long it takes the moon to orbit the Earth. So to do that, we want, here's our little sketch. Here's the moon, and the moon goes in a circle around the Earth. The period of the moon is about, wait a minute, that's what we want to find. No, I'm not going to tell you that. Okay, so let's do, here's the Earth. I'll do it in blue because I'm feeling, bluey today. And let's say the radius of the orbit. So this is r, the radius of the moon's orbit, is, I believe it is 380, oh wow, I think 388,000 kilometers, which equals 3.88 times 10 to the, let's see, it'd be 10 to the 5th kilometer, so it's really 10 to the 8th meters. That sounds about right. I think it takes a little over a second for light to get to the moon, and the radius, or sorry, the speed of light is 3 times 10 to the 8th meters per second. So that sounds about right. Okay, so there's our moon, and it is at a certain distance from the Earth, and we want to find out how long it takes to orbit the Earth. So there are two equations we're going to use here. One is that the force acting on the moon, the gravitational force acting on the moon, is going to be G times mass of the Earth times mass of the moon, which I'm going to use little m for, you'll see in a minute, divided by r squared. And the other one, and well, okay, so this equals ma, right? This is equal to the moon's mass, which is little m times its acceleration. So m equals moon's mass, which we actually don't need to know. You'll see why in a minute. And me is mass of Earth, and r is this, the radius of the moon's orbit, and then g is of course this. Okay, so this gives us the acceleration of the moon. In fact, we can just go ahead and pull this out. Acceleration, and I'm actually going to put this, yeah, why not? Acceleration of the moon is going to be capital G, and then we're dividing by moon's mass, we divide by moon's mass. So mass of the Earth divided by r squared. Okay, easy enough. So what does this, what else do we know about this? Well, we're going to call it a circular orbit. It's not quite circular. No orbit is quite circular. None of them are perfectly circular, but it's pretty darn close. So what we're going to say here is A equals v squared over r. So, and we want to find the moon's period, don't we? The period of the orbit. I'm just going to write the problem statement here. Find period of moon's orbit. I'll call it t. So, I don't know. We want to substitute in for t now. Yeah. So we want to find t. We don't want to find v, or we know r. We don't want to find v. We want to find t. We can find v, and then we'll be close. But let's go ahead and substitute in. No, what the hell? Just for fun, let's find how fast the moon is moving anyway. So the point is, this is our acceleration for circular motion. This is the moon's centripetal acceleration towards the Earth, and this is the acceleration provided by gravity. And so these two have to be the same. So we're just going to plot that equals v squared over r. Okay. So and then let's play forward with this, and I'll go to purple just for fun. And let's find the moon's, to find the moon's velocity, or the speed in orbit, we pretty much just multiply everything by r, so we get v squared equals g, capital G, times the mass of the Earth, divided by r. Well, easy peasy, right? So let's see what the hell that actually is. So we'll recall from the last one that, we know what g is, and we call the mass of the Earth is, this is equal to 5.94 times 10 to the 24th kilograms. So let's go ahead, and I even still have that almost up on my calculator. So let's see. We've got our, so this is actually what we used in the last video. This is capital G here. This is the Earth's mass, and we divided it by the radius of the Earth before. This time we're going to divide it by the radius of the moon's orbit, which we said was 3. Yeah, come on, there we go. We said is 388,000 1,000 kilometers. So I'm going to add 3 more zeros to make it meters. So 388 million meters. And now we're going to find the acceleration of the moon, which is super duper tiny. So yeah, so let's see. So that is going to be this is going to be oh no, I'm sorry, this is v squared for the moon. Wait a minute, is that right? Oh no, that's acceleration. Wait a minute. Yeah, okay, so actually I need to take out the square thing if I want to find, that's right, because now we're just using this g me over r formula to find v squared. So my mistake there. So now, there we go, that's the moon's speed in orbit. Okay, no, well, the square of the moon's speed in orbit. So let's take, man, you guys think I'm so spastic now. So this is v squared for the moon, so I'm just going to do the same calculation above and then take the square root. I could have just done square root of the answer, but I'm really not thinking well tonight. So the moon's speed in orbit, v for the moon, we found is about 1,000 meters per second. Let's call it 1,011 meters per second. Okay, so 1,011 meters per second. Okay, so all we need to do now is find the period of the moon's orbit. So 1,011 meters per second. So it's basically 1 kilometer a second as it orbits the Earth. Interesting to know. So to find the period, we take one of our handy equations for circular motion. The other one, this is one of our handy equations, is the other one, 2 pi r over v is our period. So let's go ahead and plug that in. And r here is just the radius of the moon, of course. So this is just the moon's the circumference of the orbit, you know, the path length of the orbit divided by velocity gives us time taken to travel it. Okay, so 2 times pi times 388,000, was that 88, was that right? Yeah, 88,000 kilometers meters. I feel like I'm a little off on that, but whatever. Okay, divided by the velocity, which is 1,011, and this should give us the period of the moon's orbit, which is huge, and that is, of course, seconds. So let's take the answer, and we divide by 60 to get minutes, divide by 60 to get hours, divide by 24 to get days. And what we get is 27.9 days. So 27 point, is that right? 27.9, yes sir. 27.9 days, which is about right, incidentally. A lunar month, which is the time it takes the moon to orbit the Earth, is almost exactly 4 weeks, 28 days. So you get like 12 and a half of them per year, and that's in fact where the word month comes from. It comes from moon. The time it takes the moon to orbit the Earth once. Useful little fact. That's why we have this weird ass calendar when you think about it, where we have like different lengths of month, because they wanted to do 12 months for 28 days each, but that was too short, so they started just throwing days in at random. And like, you know, your month, if you were the king, your month you'd add some days to and all. And anyway, this is all history crap and you guys don't care. So anyway, there you go. That's how you find the period of the moon from universal gravitation.